Welcome to a series of video lectures on the subject fluid mechanics. So, regarding fluid mechanics, this course is generally offered for second year engineering graduates belonging to both civil engineering and mechanical engineering, and of course, students belonging to production engineering as well as aerospace engineering disciplines also study this course, mechanics of fluids or elementary fluid mechanics or fluid mechanics in variety of names during their second year. So, what this subject is all about. So, before proceeding further, we will discuss in this subject the essential properties of fluids. So, before that, what is a fluid? And we start our discussion with the states of matter. You might have studied in elementary physics. So, what are the characteristics of different states of matter at the molecular level or at the atomistic level or at the lattice structure level regarding vibration, intermolecular forces of attraction between molecules, etc., and how to characterize different states of matter such as solids, fluids and gases. And we discuss more on the properties of fluids such as density, vapor pressure, and we'll have a detailed discussion on viscosity. And we proceed further and we classify the fluids into three, or the studies on fluids mechanics into three. Statics means fluid at rest, studies on fluids at rest. Then kinematics, essentially we are dealing with the flow properties of fluids such as velocity, acceleration, etc. Then how to measure the properties such as pressure, capillarity, etc. And we will also discuss some dynamic forces. You might have studied in solid mechanics the forces which are causing the flow to happen. We discuss about the laws of conservation, law of conservation of mass, energy and momentum with respect to the fluid element. And we of course will classify the fluid flow into different types: laminar, turbulent, then viscous flow, inviscid flow, rotational flow, etc. And we'll have a detailed analysis of or study on the flow through pipes. So this is what we intend to study in this course, fluid mechanics. So before proceeding further, you need to have basic knowledge on elementary physics, especially regarding what is the property of viscosity, vapor pressure, surface tension, capillarity, density, etc. You might have studied in elementary physics during your +1 and +2 days. And of course, in the first year you had studied mechanics of solids or solid mechanics, so you know what is a force. So what is the effect of force, resolution of forces into different components in different directions, and also you have studied couple, moment of inertia, etc. So you need to have that basic knowledge in solid mechanics also. So strain, deformation. So you have studied in solid mechanics when you apply a force, a stress is being created in the solid cross section. So that particular solid is under deformation, the strain is developed, and you have studied three: modulus of elasticity, modulus bulk modulus, modulus of rigidity, etc. So with this basic information on elementary physics as well as solid mechanics, we try to analyze and understand more on fluid mechanics. So there is a extension of the concepts you have studied in solid mechanics into the fluid mechanics. So many of the concepts are analogous between solid mechanics and fluid mechanics, and we'll study why this we will see why this course is important for engineers, especially for mechanical engineers. So we'll discuss by citing certain practical examples or engineering applications of fluid mechanics concept. So what is shown here is a compressor, an air compressor that you might have seen in compressor stations. It is used for compressing gases, especially air or any other gas. So this uses the concept of fluid mechanics because there is a fluid called air which is under compression. So this you might have studied in IC engines during your basics of mechanical engineering. This is a petrol engine or an internal combustion engine. You can see the piston movement upward and downward. So if it is a petrol engine, it is also working on the principle of fluid mechanics because it has got a charge, that is a petrol air mixture, or in petrol engines, or air only in diesel engines that is involved. So these IC engines are also working on the basic principle of fluid mechanics. So this is flow over an airplane wing or an aerofoil section when a flying object is moving through a highly viscous medium or compressible medium. So air is being blown over the aircraft wing. So there is also, you can find the application of fluid mechanics. We will discuss all these things later. Then this is again, that is launching of space vehicles. Then this is a reservoir. So a water is stored in the reservoir, and that is used for a variety of applications such as electricity generation or irrigation, etc. So you have the stored content of water, and many of the modalities of stored content of matter are based on the fluid mechanics principles. Again, this is an advanced fluid mechanics concept known as molecular dynamics or molecular simulation. So what I am trying to tell you is that many of the domestic as well as industrial applications which the mechanical engineers have to deal is basically on the principle of fluid mechanics or principle of advanced fluid mechanics. So we'll enumerate what we have just seen, that is compressing air in a compressor, that we have seen in the previous slide. Then blowing air over fans and blowers. So in our room, in our home, you can see the fans, ceiling fans. See, in our industrial practice, you might have seen blowers. So fans and blowers both are pressurizing mediums. So that works on the basic principle of fluid mechanics. So combustion of petrol or diesel in internal combustion engines. Then supersonic airflow, high velocity airflow. Then oil in a vessel. So it is a viscous fluid, oil. You might have seen engine oils. Then this is stored water in reservoirs. Then another example is motion of water in washing machines. The two examples which we have marked in red, you see. So that is different from the other two, these two examples. See, this is oil that is contained in a vessel, and the second one is stored water in the reservoir. So unlike the other two cases, these two cases consist of water or fluid or liquid which is at rest, that means which does not move. So this oil in a vessel example as well as stored water in reservoir, in these two cases the fluid is at rest. In all other cases the fluid is moving. Here also you have a rotary motion for the fluid, just like motion of water in washing machine or washing basin. So you can classify the fluids, that is what I have told at the beginning. You can classify the fluid study into different types, like as fluid at rest, that is fluid statics, fluid moving, that is fluid kinematics, etc. So what I have just told is that this fluid mechanics concept is very important for a mechanical engineer. So we'll discuss more on the statics of fluids, that is fluid at rest. That means it is not moving. You see a coffee cup that contains coffee. It is not moving, it is at rest. Velocity is 0. Okay. Of course, at the molecular level, the particles are vibrating, but there is no bulk motion for the fluid. Kinematics, fluid in motion. You see this, a pipe through which water is flowing, or motion of water through nozzles, or in IC engines, in turbines. So all this consists of the flow properties. It relates to flow properties. So that study is known as kinematics of fluid motion. And so a fluid to move, there should be for the fluid particle to be in motion, there should be a driving force. That means we need to study on the dynamics causing the flow to happen. Okay, so the action of forces. So you have the lift forces, you have an object that is flying through sky. It has got lift forces as well as drag forces acting. So study of the different forces. You might have seen inertia force in fluid mechanics, in solid mechanics. Inertia force means mass into acceleration, gravity force you have, so that is also called a body force. And we will study about pressure force. Okay, so the analysis of the forces which are causing the flow to happen with respect to fluid dynamics is termed as study of the forces which are causing the flow to happen is generally termed as fluid dynamics. So in this subject we will study about fluid statics, its properties, fluid kinematics, its characteristics, then dynamics, the relation between different forces. We'll study certain important conservation equations such as momentum conservation, energy conservation, etc. And now, so before proceeding further, we should understand what is meant by a state of matter or different states of matter. I understand you might have studied during your plus 2 solids, liquids as well as gases. Okay, so what is the essential characteristics of a solid? The essential characteristic of solid is it is having high packing at the molecular level. So it is tightly packed. So since the molecules are tightly packed, it has got very low kinetic energy. It is only vibrating from its position. So what about the deformation? If we apply a force, you have seen in solid mechanics, engineering mechanics in the first year, if we apply a force, it will deform only if the force is above a particular value. So there is a quantified deformation or a specified deformation under the action of a force, which leads to the development of stresses such as tensile stress you have studied, compressive stress you have studied, and shear stress. So what about liquids? So the packing is not so tight. That means more kinetic energy for the molecules at the molecular level. It is difficult to compress. That is why liquids are termed as incompressible in nature compared to gases. So what about the shape? It is occupying the shape of the container. Okay, so it is having indefinite force, and the most important one is it is having continuous deformation under the action of a force. That means if we apply a force, it cannot resist the deformation. So it will deform continuously, it cannot resist. So that it creates shear stress. That we'll discuss later, the development of shear stress in viscous fluids. Gases, which are also having similar characteristics, loose packing at the molecular structure. So it spread out indefinitely and will expand to fill the container. It is highly compressible. Unlike liquids, the gases are highly compressible, and we have a separate category of fluid mechanics, a classification of fluid mechanics called compressible fluid flow or gas dynamics, essentially that deals with air. Okay, so it is also having continuous deformation under the action of forces. So these liquids and gases, which are collectively known as fluids. So what is the common characteristics? The deformation is continuous. Unlike solids, fluids are having continuous deformation under the action of a force. So this is an example of this is the representation of solid blocks. Then you can see this is a liquid, then gas, smoke, or air, that is example of gas, alcohol, benzene, etc. Water, these are examples of liquids. Ice, stone, wood, examples of solids. So the classification is essentially based on the density or the packing, extent of packing of molecules. So in addition to these three states of matter, we have plasma as the fourth state of matter, and of course the Bose-Einstein condensate as the fifth state of matter. That is outside the scope of this syllabus. And now we will consolidate what we have just discussed in the previous slides. So liquids and gases are collectively termed as fluids. Okay, so what are the common characteristics of fluids? It fills out the container, the shape of the container, because okay, it is having high molecular level vibration compared to solids. So high kinetic energy, large kinetic energy, continuous deformation, no definite shape. It occupies the shape of the container. So these are the common characteristics of fluids, liquids and gases together. And of course, Some examples of fluids. Already I have stated water, alcohol, kerosene, benzene. These are examples of liquids. Steam as well as vapor of liquids. So what is the essential difference between steam and a vapor? So steam, if you take water, its normal boiling point at 1 atmospheric pressure is 100 degrees Celsius. So 100 degrees Celsius water is termed as water vapor. Okay, water vapor. If the temperature of water vapor is above 100 degrees Celsius with pressure remaining constant at 1 atmosphere, if the temperature of water vapor is increased above 100 degrees Celsius, suppose it is 102 or 103 degrees Celsius, it is called superheated vapor. Okay, it is called superheated vapor. Such superheated vapor are known as vapors are known as steam. So of course there is a difference between steam and water vapor. So both are coming under the category of fluids or gases. Then petrol, diesel, air, mixture of gases. These are some of the examples of fluids. So as mechanical engineers, we need to come across a variety of fluids, its characteristics, its analysis during our study of the different topics of mechanical engineering, especially thermodynamics, thermal systems, thermal engineering, compressible fluid flow, refrigeration and air conditioning. Because in refrigeration and air conditioning we use a fluid called as a refrigerant. Okay, in compressible fluid flow or gas dynamics we use the fluid air that is highly compressible. Okay, in open channel flow we use water that is passed through channels which are stored in reservoirs. In hydraulic structures like dams and canals and reservoirs. So all these engineering applications or future semester studies of mechanical engineering requires fundamental and basic knowledge on the fluid mechanics. So we'll study on statics, kinematics and dynamics, and we'll proceed further in the subsequent video sessions. Thank you.